In this lesson, we're going to look at polygons in the coordinate plane. And the objective is to classify polygons in the coordinate plane based on the properties of different quadrilaterals that we've learned. So we're going to be using three different formulas that you've already had these formulas in the past. We're going to use the distance formula, midpoint formula, and the slope formula to determine if certain sides are congruent or diagonals are congruent, if diagonals bisect each other, if sides are parallel. Those kind of things are what we're going to be looking at in the coordinate plane. So let's review these. The distance formula, you're going to use it to determine if sides are congruent or if diagonals are congruent. So here's the distance formula to refresh you on that. Distance d is equal to the square root of the difference between your x coordinates squared plus the difference between your y coordinates squared. The midpoint formula, we're going to use it to determine if to determine what the coordinates are of the midpoint of a side. So the coordinates of the midpoint of a side. And you're also going to use the midpoint formula to determine whether diagonals bisect each other or not. And then finally, we're going to use the slope formula. And we're going to use the slope formula to determine whether opposite sides are parallel or whether diagonals are perpendicular, like in a rhombus, or whether the sides are perpendicular. Because if the sides are perpendicular, then that means there's a right angle, like in rectangles and squares. So the slope formula, just as a refresher on that one, m is equal to your change in y divided by your change in x. So let's look at a few problems. In problem 1, we're classifying a triangle. You have to determine whether triangle RST is scalene, isosceles, or equilateral. So just to review those definitions, scalene means none of the sides are equal. Isosceles means at least two of the sides are equal. And equilateral means that all three of the sides are equal. So to determine the length of a side, to determine if sides are congruent or not, you're going to have to use the distance formula. So let's look at the coordinates of each vertex. Okay, the coordinate of R is -4, 1. The coordinate of S is 3, 3. And the coordinate of T is, can't see it, 1, yeah, 1, -3. So now let's look at the length of each side. So let's first take the length between R and S to get that side. So apply your distance formula, square root, the difference between the x coordinates, so -4 minus 3 squared, plus the difference between your y. Got to go in the same order. I chose the x coordinate from the R first, so I have to choose the y coordinate from the R first. So y minus 3, parentheses squared. And that is, if you plug it in your calculator, 7.28011. Okay, so that was side RS. So now let's look at side ST. So between S and T, it's going to be the square root of the difference between your x values, 3 minus 1, parentheses squared, plus the difference between y values. 3 minus a negative 3 is 3 plus 3, parentheses squared. Put that into your calculator and you get 6.32456. And then the third side is between the r and the t. So RT is equal to the square root of, difference between the x values is negative 4 minus 1, parentheses squared, plus 1 minus the negative 3, which is 1 plus 3, parentheses squared. Put that to your calculator and you're going to get 6.40312. So none of these sides are equal. So that means that it is a scalene triangle. In problem 2, we need to classify the parallelogram and indicate whether it is a rhombus or not, and explain why. So one of the properties we learned about a rhombus from the last lesson was that the diagonals of a rhombus are going to be perpendicular. So let's look at the slopes of these diagonals. And if they have opposite reciprocal slopes, that means they're perpendicular. And that'll prove it for us. So let's look at this. Since it is on the coordinate plane, we can just count. Rise over run would be the easiest way to do that. So let's look at the slope of diagonal CD. So we're looking at this diagonal between C and D. And we need to find the change in y over the change in x. I'm going to use the Greek letter delta, which looks like a little triangle, to indicate change in y and change in x. So if we look at that, let's pick 2 points on the line. So let's just pick the point at point D and the point where the diagonals cross. So I'm picking 2 points that are exactly on the line, and my rise, I'm going to go up 4, so that's a positive 4 for my change in y, and then I'm going to go left 3, so that's a negative 3 for the change in x for my slope of segment CD. So now let's look at the other diagonal. Let's look at the slope of AB. And once again, we're looking at change in y over change in x. So let's go from point A and see what movement it takes to get to that point where the diagonals cross. I have to go up 3, so that's a positive change of 3, positive y, and then I go right, 4, so that's a positive 4 for my change in x. So you have the slope of each of these now, so the slope of CD is a negative 4/3, and the slope of AB is a positive 3/4. Those are opposite reciprocals, so I can say that CD is perpendicular to AB because the slopes are opposite reciprocals. So yes, ABCD quadrilateral is a rhombus. And the last problem, we're classifying a quadrilateral, and it asks you to determine what is the most precise classification of the quadrilateral that's formed by connecting the midpoints of the sides of this isosceles trapezoid. So we have to begin by finding the midpoints of the sides of this isosceles trapezoid. It's easy to do the horizontal lines because you could just take the length of the line and divide it by 2, and that's your midpoint. So on the first one, the midpoint between O and N, the top, that's a length of 6. So let's go over 3 and mark that point as a midpoint of that side. And then on the bottom, we can look at between L and M, and the length is 1, 2, 3, 4, 5, 6, 7, 8. So we can go over 4, 1, 2, 3, 4, and mark that midpoint. That one was easier to find than the sides will be. Okay, so we can mark that as a midpoint. Now, to find the midpoint of LO and MN, we're going to have to use the midpoint formula. So let's look at the coordinates of the vertices of this trapezoid. O is at -3, 3. N is at 3, 3. M is at 4, -2. And then L is at -4, -2. So let's determine the midpoint of side LO. So to determine the midpoint, you're going to have to take, you add the two x values together, which is the -4 plus the -3. And then you add, and you divide that by 2. And that's your x coordinate. And then for your y coordinate, you add the 3 and the -2, your y values, and divide that by 2. So that's going to be your midpoint of LO. So my midpoint of LO is going to be -7/2, comma, 1/2. Okay, that's -7/2, comma, 1/2. That's this point over here on this side. The point on the other side, use the same method. Add your x values together between M and N, which is 3 plus 4 is 7 divided by 2, because that's going to be 7/2 for your x value. Add your two y values, which is 3 plus a -2, that's 1. Divide that by 2, you're going to get a positive 1/2. So those are the points that are going to be used to form the quadrilateral that connects the midpoints of each side of that isosceles trapezoid. So once again, let's name these points, make it easier to reference. And let's name that one A, B, C, and D. Those are the vertices of that quadrilateral that's formed inside there. The coordinates B is going to be 0, 3, and the coordinates of D is going to be 0, -2. And then we've already got the coordinates of the midpoints of those two sides. So now we have to determine what kind of quadrilateral that is in the center. So let's look at the lengths of its sides to see if the length of the sides are congruent or not, because that would potentially classify it as a rhombus. So between B and C, let's look at the length distance formula. Between B and C, we have 0 minus 3.5 parentheses squared. That's the difference between your x value squared, plus the difference between your y value squared is 3 minus a half squared. Put that in your calculator, and you're going to get 4.301162634. We'll just put several digits out there. Okay, so that was the length of BC. Work your way around. CD is the square root of difference between your x values between points C and D is 3.5 minus 0 parentheses squared plus the half 0.5 plus 2 in parentheses squared. Put that into your calculator. And you are going to get the same value. 4.301162634. AD, difference between your x values between A and D is 0 plus 3.5 parentheses squared plus difference between your y's, negative 2 minus a 0.5 parentheses squared. If you plug that in, you are going to get the same value. And between A and B, same thing. Look at the difference between your x's. You got a negative 3.5 minus 0 parentheses squared plus the 0.5 minus 3 parentheses squared. Plug that in, and it is the same as well. So you have BC equal to CD equal to AD equals to AB. So all the sides are congruent, so that means that it is a rhombus. Because all sides are congruent, but the sides, consecutive sides, are not perpendicular. We can look at the diagram and see that they're not right angles. So it's not a square, it is just a rhombus.